You know, when we think about unexplored frontiers, we usually look up at the stars. But what if I told you one of the most alien worlds is right here, in your own backyard? Today, we're taking a trip, a journey into a hidden universe that operates by a completely different and frankly bizarre set of rules. So let's dive in.
And this quote really sets the stage perfectly. We're not talking about some far-off theoretical place. The nanoworld is literally all around us. It's in a speck of dust, a grain of pollen, even in the cells of your own body. We just have to, well, change our perspective to see it.
So that's what we're going to do. We're going on a journey of scale. We'll start in the world we all know and understand, and then we're going to shrink ourselves down, step by step, into a realm that gets stranger and stranger until it becomes, well, completely fantastical.
Okay, so here's our roadmap for the trip. We start with us, a person. Then we take a huge leap down to the size of a flea. Then another massive jump to a single grain of pollen. From there, it's down to a virus. And finally, all the way down to the fundamental building block of everything we know, a single atom. Each of these steps isn't just getting smaller, it's like entering a whole new dimension.
But first, let's ground ourselves. We'll start here, in the macro world. This is our reality. The world of people, cars, coffee cups, you get it. It's all governed by a set of physical laws that feel totally intuitive, just because we live with them every single day.
Right? In our world, the rules are simple. Gravity holds us down. Inertia is that feeling that pushes you back in your seat when a car speeds up. Heat, we just think of it as molecules vibrating faster. And static electricity, I mean, it's a fun party trick with a balloon, but it's basically just a tiny distraction. These are the rules we know and trust. But what happens when we start to shrink?
Okay, let's take that first big step down. Welcome to the microworld. This is the home of tiny things like bacteria and pollen, and down here, well, those familiar rules we just talked about, they start to weaken, they start to bend. This is where physics starts to get a little weird.
And this table just lays it all out. Look at this. Gravity, which rules everything for us, becomes weak, forgettable almost. And electrostatics, that little balloon trick, down here, it's actually kind of scary. It's a powerful force. And heat is no longer just simple motion. It's something called a Brownian jostle. Imagine you're a dust mote in a drop of water, being constantly slammed from every direction by water molecules. You're just being shoved around in a chaotic dance. The forces we thought we knew are completely changing rank.
And that chaos brings us to our final destination. We're going all the way down to the nanoworld. This is the scale of viruses, of individual molecules and atoms. And here, physics hasn't just bent. It has gone completely, utterly wild. Seriously, welcome to the bizarre.
In this world, all of your intuition just goes right out the window. For starters, energy isn't a smooth ramp you can walk up. It's quantized. It only exists in specific little packets. It's like a staircase. You can be on step 1 or step 2, but you can never, ever be in between the steps. And electrons, they aren't little planets orbiting a nucleus. Nope. They're more like fuzzy clouds of pure probability. The rulebook has been totally rewritten.
So, it's one thing to hear these mind-bending rules, right? But what does it actually mean? What's it like to exist in the nanoworld? What are the real consequences when physics goes this haywire?
Well, for one thing, walking on the ceiling would be a piece of cake. Seriously, at this tiny scale, surface forces like static cling are so powerful and gravity is so ridiculously weak that you just stick. Think of a gecko climbing a wall, but 1,000,000 times more effective.
And remember inertia, that force that makes it hard to stop a moving train? Down here, it barely exists. It's almost completely irrelevant. Things can start, stop, and zip around, changing direction instantly with none of the momentum we're used to.
Now this one is my absolute favorite because it just flips everything we think we know on its head. In the quantum world, you can know exactly where something is or exactly how fast it's going, but you can never know both at the same time. So a perfectly stationary object, one whose speed you know is 0, has a location that is, by definition, a complete blur. How wild is that?
Okay, so after that wild trip, you're probably thinking, this is fascinating, but why does any of this matter to me? And that is a totally fair question. So let's zoom back out and talk about why this bizarre little world is actually incredibly important for our future.
Because figuring out the nanoworld isn't just some fun academic exercise. It is the absolute key to the next wave of human invention. When you can understand and control matter at this fundamental level, you can build things, create materials, do things we've only ever dreamed of. And it is already happening right now. Just look at the impact nanoscience is having. In medicine, we're talking about tiny robots that can hunt down cancer cells. In engineering, it's about creating materials that are stronger than steel but light as a feather. And in electronics, it's why our computers get smaller and faster every single year. This tiny world is having a massive impact on ours.
And you know what that means? It means incredible new opportunities. Of course, you have the obvious fields like biology and chemistry, but it's popping up in the most surprising places. Nanotechnology is being used in criminology to find microscopic evidence. It's being used in space science to build next-generation spacecraft. The future isn't just about thinking big, it's also about thinking incredibly, incredibly small.
So, the next time you're just looking around your backyard, take a second. Remember that there's an entire universe of strange physics and unbelievable possibility hiding just beneath the surface of what we can see. The biggest discoveries of our lifetime might not come from looking up at the stars, but from looking down into the land of the small. And the only question left is, what are we going to find there next?